Welcome to the DIY Honda Garage channel. The DTC P26E4-01 indicates a problem with the starter cut relay 2 control circuit in the Honda CR-V 2023 and newer models. This diagnostic trouble code arises when the powertrain control module, or PCM, detects that the return signal from the starter cut relay circuit is low when the starter is meant to be off. A low voltage in this context suggests that there is an issue either with the relay itself, the related circuitry, or the PCM. The starter cut relay is critical in controlling whether the starter motor can operate, and hence, any failure in this system can prevent the engine from starting. It is usually located within a relay circuit board that is accessible under the dashboard or in the fuse box area. Proper diagnosis is essential to identify the specific fault, as it may require testing multiple components before pinpointing the exact source of the issue. The starter cut relay 2 plays a crucial role in the Honda CR-V's ignition system by controlling the starter motor's operation. When the starter is engaged, this relay allows electrical current from the battery to flow to the starter motor. If the PCM detects that the signal from the starter cut relay is low when it shouldn't be, it interprets this as a fault, storing the DTC. The PCM, or powertrain control module, is usually found located near the dashboard, specifically behind the glove compartment in newer models. It receives input signals from various sensors and controls the relay to ensure proper engine startup functionality. Understanding the signal flow from the ignition switch to the relay circuit and back to the PCM is essential for diagnosing issues effectively. By reviewing the circuit diagram and the components' locations provided in the manual, technicians can get a clear picture of the paths that electrical signals take during normal operation. There are several potential causes for the DTC P26E4-01. First, a faulty starter cut relay could be preventing proper operation by failing to switch on or off as required. Second, there may be wiring issues, such as corroded connectors, broken wires, or poor grounds that lead to incorrect voltage readings. Such conditions can result in low voltage signals being sent back to the PCM erroneously. Third, a malfunctioning PCM itself could interpret signals incorrectly due to internal faults or software errors, leading to a low voltage detection when in fact the system is functioning properly. It's essential for technicians to follow the troubleshooting steps so that each component is evaluated systematically to determine if it is functioning within specifications. When the DTC P26E4-01 is present, several symptoms may occur, significantly affecting the vehicle's operability. One of the predominant symptoms is that the engine may fail to start altogether. This happens because the starter cut relay is preventing the starter motor from receiving power. Additionally, the driver might notice no response from the starter when the ignition key is turned, indicating that the relay is not engaging. Furthermore, the vehicle's onboard diagnostic system would typically trigger the check engine light, alerting the driver that a fault has been detected. Understanding these symptoms is crucial for quickly diagnosing and resolving the problem, thus ensuring the vehicle returns to proper operating condition. The first step in troubleshooting the DTC P26E4-01 involves bringing the vehicle to the on mode. This means turning the ignition key to the on position without starting the engine, allowing for a voltage check on the relay circuit. With the relay circuit board connector A disconnected, technicians will then perform specific inspections to ascertain the integrity of the starter cut relay circuit. The goal is to check the voltage levels at the terminals for IG1 ACG and IG1 starter cut circuits. Under normal conditions, the voltage should read at least 12 volts, confirming that power supply to these circuits is intact. If the voltage is lower than expected, this indicates an abnormality in the circuit that requires further investigation. Documenting these findings accurately will help in narrowing down the exact failure point for effective repair. Continuing with the troubleshooting, the second step requires inspection of the ST-cut RLY2CL circuit. Before proceeding, ensure that the SCS line is jumped using the Honda Diagnostics System, HDS, for a minimum of 1 minute. Once this is completed, both the relay circuit board connector A and the PCM connector A must be disconnected. The main objective at this stage is to check for any open wires and shorts within the ST-cut RLY2CL circuit. Technicians will measure the resistance. Ideally, the measurement should show less than 1 ohm when checking for open wires, while for shorts to ground, it should read more than 1 megohm. If the readings do not meet these specifications, it indicates a fault within the wiring that must be rectified. Persistence in following through with every inspection is critical to ensure the reliability of the diagnostic process. In the third and final step of troubleshooting for DTC P26E4-01, a detailed inspection of the powertrain control module, PCM, is necessary. If all previous inspections have returned normal results, the suspicion shifts to the PCM as the potential faulty component. During the PCM inspection, technicians need to evaluate whether the module is processing input signals correctly and responding appropriately. This may involve checking the software for any bugs and ensuring that the connections to the PCM are secure and free of corrosion. If abnormalities or errors in the PCM operation are identified, it is likely that it requires replacement. Documenting all inspection results on the PCM will provide valuable information for future troubleshooting and repairs, contributing to a thorough understanding of vehicle behavior in cases of similar faults. Once repairs are made following the troubleshooting steps, the next phase is to conduct final verification to ensure that the issues associated with DTC P26E4-01 are resolved. This involves running diagnostic system tests through the Honda Diagnostics System, HDS, to confirm that the starter cut relay is functioning correctly. After completing a thorough verification, clear any diagnostic trouble codes from the system. This step helps in resetting the vehicle's onboard computer, allowing it to run fresh diagnostics without interference from prior codes. Post-clearance, technicians need to start the engine to verify that everything operates smoothly without re-triggering the DTC. Successful completion of this verification phase indicates that the electrical system is now functioning as intended, restoring the vehicle's ability to start reliably. To help prevent issues akin to the DTC P26E4-01, engaging in regular preventive maintenance is crucial. Routine inspections of electrical components, such as the starter cut relay and related wiring, can help identify potential issues before they result in critical failures. Ensuring all connections, especially in the relay and PCM, are clean and free from corrosion reduces the chances of voltage and signal disruption. Utilizing dielectric grease on connections can inhibit moisture ingress, which is a common cause of corrosion in vehicle electrical systems. Being proactive with maintenance ensures components are functioning at optimal levels and diminishes the likelihood of mishaps. Keeping electrical systems in top condition not only prolongs the lifespan of components, but also enhances the overall reliability of the vehicle. In conclusion, understanding and diagnosing DTC P26E4-01 associated with the Starter Cut Relay 2 is vital for effective repairs in the Honda CR-V 2023 and newer models. This code signifies important failures potentially affecting the vehicle's startup functionality. Key components that are scrutinized throughout the troubleshooting process include the starter cut relay, associated wiring, and the PCM. Adhering to the outlined troubleshooting steps ensures that technicians systematically evaluate each part of the system for faults, leading to accurate diagnoses and efficient repairs. Through informed inspection and preventative maintenance, issues related to low-voltage signals can be minimized, allowing for smoother vehicle operation and enhanced reliability. Emphasizing these practices will contribute to the ongoing performance and dependability of the Honda CR-V. Please like and subscribe to the channel. See you next time!